Imagine finding an object on the street that clearly doesn't belong in your neighborhood. Now multiply that feeling by billions. This visitor came from another star system, traveling through space for 7 billion years before crossing our path. My friends, this is happening right now. An object called 3I Atlas is cutting through our solar system at 137,000 miles per hour, carrying secrets from when our galaxy was young. And you know what's most impressive? We have a secret weapon to unravel these mysteries, the Vera Rubin Observatory. If you're ready to discover why this object could rewrite our understanding of the cosmos, hit that like button and let's take this journey together. You know what's truly rare in the universe? It's not diamonds, we find tons of them on Earth. It's not gold. There are asteroids full of it. What's really rare are interstellar objects that we can actually detect. In all of human history, just three. 3 confirmed visitors from other star systems. The first was Oumuamua in 2017. So strange we still don't know what it was. The second, 2I Borisov in 2019, at least behaved like a normal comet. And now we have 3I Atlas. But here's the plot twist that's going to make you question everything. This might be the oldest object we've ever studied. 7 billion years old. That means when our sun didn't even exist yet, this chunk of rock was already wandering the galaxy. To put that age in perspective, let me tell you a cosmic story. 7 billion years ago, our galaxy was a very different place, more violent, with star formation rates much higher, supernovas exploding with frightening frequency. The first generations of stars were dying and spreading heavy elements through space for the first time. In that chaotic and primordial environment, 3I Atlas formed. It witnessed the birth and death of billions of stars, survived gravitational encounters with entire stellar systems, and navigated the galaxy for a time so long it's difficult for our human minds to comprehend. It's literally a walking fossil from cosmic youth, carrying in its chemical composition the signatures of an era when the universe was learning how to make the elements that would eventually form planets like Earth. And wait until you discover the impossible speed of this object. We'll come back to that shortly, because it's going to challenge everything we know about orbital physics. Let me tell you something that's keeping astronomers awake at night. There's a clear line between objects in our solar system and interstellar visitors, the escape velocity. Oumuamua, 16 miles per second. 2I Borisov, 20 miles per second. High speeds, but expected. 3I Atlas, 38 miles per second. To put this in perspective, and here's where my nerdy side gets excited, if you could travel at that speed, you'd go from New York to Los Angeles in less than a minute. It's so fast that even if we wanted to send a probe to intercept it, it would be impossible. Our best spacecraft would look like turtles trying to catch a supersonic jet. It's like the universe is saying, here's an incredible gift for you, but good luck trying to catch it. This extreme speed tells us a dramatic story. This object was ejected from its original system by something violent, maybe a supernova or an encounter with a black hole. But here's where the physics gets really fascinating. That speed of 38 miles per second isn't just fast. It tells us exactly where 3I Atlas came from and what kind of cataclysmic event sent it our way. When we model this object's reverse trajectory, we discover it originated from the thick galactic disk, a region populated by population 2 stars, ancient metal-poor stars that formed when our galaxy was still settling down. For an object to reach this speed, it needed an extreme gravitational slingshot. We're talking about scenarios like a companion star exploding in a supernova and literally kicking 3I Atlas out of its system, or perhaps a close encounter with a stellar black hole that accelerated it to relativistic speeds before ejecting it into interstellar space. This is extreme astrophysics in action, the kind of event that happens maybe once every million years in a typical stellar system. But wait, stop everything. Before we continue with the physics, let me ask you a question that's going to change how you see this object. What if I told you that 3I Atlas might be too big to exist? Here's where our story challenges the laws of cosmic probability. Size estimates for 3I Atlas range from 0.5 to 15 miles across. Now, 0.5 miles? Normal, but 15 miles? That's bigger than the asteroid that killed the dinosaurs. And here's the problem that's leaving scientists perplexed. In the universe, the bigger the object, the rarer it is. It's a cosmic pyramid, trillions of small objects at the base, few giants at the top. Statistically, we should see hundreds of thousands of small objects before finding a giant. But in just 3 detections, we already have a possible giant. It's like going fishing for the first time, and in your first 3 attempts catching 2 minnows and a whale shark. Either the universe is trolling us, or there's something we don't understand about these objects. And speaking of things we don't understand, wait until you see the bizarre color of this object. It could rewrite our understanding of chemistry in the early universe. The reddish coloration of 3I Atlas isn't just pretty, it's a chemical biography. And that biography is telling us something that shouldn't be possible. This color indicates complex organic compounds, the building blocks of life. But if 3I Atlas really is 7 billion years old, that means these compounds formed when the universe was half its current age. Think about it. We're seeing life chemistry from an era when we thought the cosmos was too chemically primitive for this. It's like discovering your great-grandparents already had smartphones. And there's more. The object appears to be water-rich. Water preserved for billions of years, carrying information about conditions in the young universe. It's a walking chemical archive of cosmic infancy. But things get even stranger when we look at where this object is heading. 3I Atlas is doing something statistically improbable, moving almost perfectly aligned with the plane of our solar system. Space is 3-dimensional. Objects can come from any direction. The probability of such precise alignment is like flipping a coin and having it land standing on its edge. It can happen, but when it does, you start wondering if there's something more going on. And here's something nobody expected. In October, 3I Atlas will pass so close to Mars that our Martian orbital probes can observe it in detail. For the first time in history, we'll have Martian observations of an interstellar visitor. Mars finally gets its chance to do astronomy. Who would have thought the red planet would become our space observatory? But now let me tell you about something that's going to change everything we've just discussed. There's a telescope that's about to revolutionize our understanding, not just of 3I Atlas, but of the entire universe. And it has a name that carries one of modern astronomy's greatest discoveries. The Vera Rubin Observatory isn't just a telescope, it's a time machine that will photograph the entire sky every 3 nights for 10 years. Imagine a time-lapse movie of the entire observable universe. 3.2 gigapixel camera, the largest ever built. To display a single image at full resolution, you'd need 378 4K televisions. And here's the revolutionary part. AI algorithms will automatically process these images, detecting anything that moves. Vera Rubin, the astronomer who gave the observatory its name, discovered that 85% of the universe is made of invisible matter, dark matter. She literally showed us that we don't know what the cosmos is made of. And now, the telescope bearing her name will hunt interstellar objects. The estimates? Between 0 and 70 objects per year. In a decade, we could go from knowing 3 to knowing thousands. And this brings us to the biggest mystery of all, one that might finally be solved. Oumuamua did things that natural objects shouldn't do. It accelerated when it should have decelerated. It had a cigar-shaped form. It showed no cometary activity, but behaved as if it had some kind of propulsion. All natural explanations ran into problems. Hydrogen iceberg? Doesn't survive in interstellar space. Natural solar sail. Would require impossible density. And then there was the most controversial hypothesis, artificial origin. Now, I'm not saying it was an alien spacecraft, but I am saying we can't completely rule out that possibility with the data we have, and that makes me scientifically uncomfortable, which is exactly where science needs to be. Vera Rubin will give us the definitive answer. If Oumuamua was natural, we should see more similar objects, but if it remains unique after years of observations, well, the mystery will get even deeper. But forget for a moment everything we've talked about regarding past mysteries. Let me paint you a picture of the future that might be closer than you imagine. With Vera Rubin detecting interstellar objects in advance for the first time in history, we have the real possibility of intercepting a visitor from another star system. Imagine this. An object is detected several astronomical units away. We have months to plan. A probe is quickly assembled and launched. For the first time, we touch material from another world. This isn't science fiction. Space agencies are already discussing rapid intercept missions, probes that can be assembled in months when an interesting target appears. Think about what this means. Directly analyzing material from another star system, studying chemical composition from cosmic eras we never thought we could access. It would be like having a chemical time machine. And if artificial objects really are wandering through interstellar space, Vera Rubin would be the first to detect them. We could finally answer, are we alone? The implications of a successful intercept mission go far beyond simple sample collection. We would literally be touching the history of another star system, analyzing material that formed under completely different conditions from what we know. Imagine discovering isotopes that don't exist in our solar system, or elemental proportions that reveal unique nucleosynthesis processes from stars of different masses and ages. We could find evidence of cosmic ray impacts that occurred during the interstellar journey, giving us insights into the density and composition of the interstellar medium. Even more fascinating, if the object contains preserved organic compounds, we could be analyzing prebiotic chemistry from another world, perhaps discovering that life's building blocks are universal, or maybe finding forms of organic chemistry that are completely alien. And here's a possibility that gives me scientific chills. What if we find structures or patterns that can't be explained by known natural processes? I'm not necessarily talking about alien technology, but perhaps physical or chemical processes we haven't discovered yet. Phenomena that only occur under extreme interstellar conditions we've never been able to replicate in the laboratory. So, recapping our cosmic journey, we have 3I Atlas, a 7-billion-year-old object cutting through our system at impossible speed, carrying chemistry that shouldn't exist, on a statistically improbable trajectory. We have Vera Rubin about to begin a decade of discoveries that will transform astronomy. And we have the real possibility of intercepting visitors from other worlds. But you know what's most impressive? We're living in the unique moment in cosmic history where we finally have the technology and knowledge to not just detect these messengers from the cosmos, but to truly understand them. 3I Atlas might be just the beginning. In the coming years, each new interstellar object will be a window into a different star system, a different era of cosmic evolution. The universe is constantly sending letters to us in the form of these objects, each one written in chemical and physical language, waiting to be deciphered. If this journey through interstellar mysteries has expanded your cosmic horizons, hit that like button. It helps the algorithm bring science to more people. Subscribe so you don't miss the next revolutionary discoveries, and ring that notification bell because the universe never stops surprising us. Let me know in the comments. Do you think we'll discover more objects like Oumuamua, or will it remain unique? And what do you expect Vera Rubin to discover? Remember, we are stardust connected to the cosmos in ways we're only beginning to understand. And with each interstellar visitor, we discover even deeper connections to this extraordinary universe we call home. Until the next cosmic mystery, keep looking up.